So for this assignment, we're going to use CMG, which is a reservoir simulating model, to create our own little homogeneous rectangular reservoir, and we're going to see how we can use it to predict the original oil and gas in place, as well as the production of a well if we were to create one in that reservoir. So first off, what we're going to do is open the launcher. So this is the CMG Technologies launcher, and now we're going to use this builder. Make sure you're on the 2017, by the way, just because it could cause some compatibility issues later with your files. So now that we've got the builder open, we're going to create a new file. It's going to be a IMEX simulator, and we're going to go ahead and use field units, and we're going to start this in 1901. So you can go ahead and click OK here. And so this is the main interface page. So you can see all these red X marks here. We've got to turn them green before we can run any simulations with this. So let's start filling out all these different properties. So first we're going to create a grid, so Cartesian grid, and since this is a 510 by 510 reservoir, what we're going to do is we're going to make 51 blocks in the I and J directions, and then we're going to make one vertical layer. And so these blocks are going to have a width or a thickness, I guess, of 10. So we're going to make 51 times 10. So that's basically telling CMG the notation you have to use to tell it that we're having 51 blocks. So that number has to match times 10, which is the size, the width. And so we're going to do that for both of them. And so here we've got the grid created. And now let's fill it up with some properties. So since this reservoir is 7,000 feet deep, we're going to make the top of the reservoir, the grid top, is going to be at 6,990 feet. We're going to have a thickness of 10 feet, porosity of 0.2, and we're going to have a permeability of 10 millidarcies. And so for the I and J, we can just use this equals, and it allows us to set the porosity in the J direction equal to that of the I direction, and since it's homogeneous, we can also do it for K, so its permeability is the same in all directions, and that's all we're gonna need for this. We can just click OK here, and we're also gonna need to fill out this rock compressibility. So for this reservoir, we're gonna assume that we have a rock compressibility of 3 times 10 to the negative 6. So we can click OK there. And now we can start filling out the components. So let's see. We're going to use a black oil model using correlations. So we're going to set this reservoir temperature to 130 Fahrenheit. Let's just say we create data up to 4,500 psi. Just make sure we cover everything up to our initial pressures at least. And so the bubble point pressure is actually going to be a value that we provide. So we're going to tell it that our bubble point is 1200 psi. So this oil density we're going to use is a stock tank oil gravity, just to make it a little simpler here. So we're going to put 0.9, so it's 90% of the density of water, and the gas density, we're actually going to use the gas gravity as well, and we're going to use a gas gravity of 0.8. So reference pressure is fine, pressure dependence is fine. Okay, so now we click OK, and you'll see how it generates these properties such as BO, the formation volume factor, and RS. And so something that's important to note is that CMG actually kind of does something funky with the numbers, and so you'll notice that even after the bubble point, these BO just keeps going up, and RS as well. When what we've learned from class is that RS should actually be constant after the bubble point, and BO should in fact start going down. So that's something that's important to note, and it's something that we can see here. So if you double click on this PVT region 1 again, it'll give you a little short summary of some of the things that we input, give you the compressibility of water, as well as the densities. And so this is the PVT table that was actually created using correlations similar to that we've learned in class. So you've got your pressure and all these different properties of the reservoir fluid, and these are some things that are important to note because you might have to use them for other parts of your homework. And you can actually change this gas expansion factor, so expansivity. You can get the BG from it. You could also get the Z factor as well, so it's important to note. And you can just copy and paste this table into Excel and use it for other calculations. And I will remind you again that after the bubble point, these values are not correct. So what you're going to want to do is for BO, use a correlation, like one of the ones that relates it to the compressibility, for instance, after the bubble point. And since CMG kind of alters things after the bubble point, I would just use this compressibility here, which is not technically 100% correct, but for the purpose of this assignment, you should get some good BO values using that 3 times 10 to the negative fifth. And for RS, of course, constant after the bubble point. So now we can go ahead and click OK. We've got our components. Now let's take a look at the rock fluids. So we've got to get this rock fluid type. So we actually have to create a new rock type. So now that we've got this here, let's go ahead and unclick that capillary pressure. We won't be needing that. And let's go ahead and generate a table using correlations. So this is actually something that you probably have not learned yet, but it's basically the relative permeability curve. So you'll learn more about this in petrophysics. And what we can do is use these things called Corey functions to predict the relative permeability of water, oil, and gas in multi-phase flow. And so I won't go too in depth now, but these are the certain values that you'll have to input for the purpose of this assignment, just so that CMG can generate some more fluid properties and predict what we need for the simulation. So 0.1, 0.1. So this is actually your initial water saturation. This is where it comes into play here, that connate water endpoint saturation. And these are the endpoint residual oil saturation. So this is the maximum amount of oil you can get out up to this point. Connate gas, relative endpoint saturation. And these are these Corey exponents, which are just going to be 2 that is used. So go ahead and click apply, OK. And so now we should have our relative permeability curves. So here you can see the relative permeability of oil versus the relative permeability of water. And so CMG will use that to predict flow. And so now we can specify our initial conditions. So since we know this is a black oil reservoir, let's just go ahead and click only water and oil initially, add initial conditions. So the pressure is going to be 3200 psi at a depth of 7,000 feet, and we're going to go ahead and make this water oil contact at 7,100 feet, just to make sure that there's no water in the range of our reservoir, so we won't get anything flowing in there. And we're going to have a constant bubble point pressure, so that's going to be that 1200 psi. Apply and click OK. So now we have our reservoir laid out, but now we need to put a well in it. So we can double click on this well. So let's give this well a name. I'll just give it producer, and make sure you clarify on the type. So this is a producing well. We don't really need a group for this assignment. So you need to check on this constraint definition box, and we're going to make this an operating well. And so we're going to operate this well based on not the bottom hole pressure, but instead the total reservoir fluid rate. So these are these reservoir barrels. And we're going to make our value was given 10 barrels per day. And that's all we need to do on this. Now we need to actually give this well a location. So you double click here on this 1901, and so this gives you a little bit more information on your well, and we are actually going to make a perforation. And so we're going to make it dead center of the in the middle of the reservoir, so we can zoom in a little bit here and then click on this begin button here. And so we're going to look for the grid block 2525-1. So we got that. So it's the center of our reservoir there, and we've got that perforated. So apply OK, and that well is ready to produce. But now we need to give CMG a timeline. So we can double click on that date, and we're going to add a range of dates. So this starts on day 1 of 1901, and we're going to run this simulation for 2 years. So let's just go to 1903. That's 730 days. Click OK, and make sure you change the steps here to day, so we can get kind of more detailed data of how our well is producing day by day. And that's all we need for this. And so now we are ready to start the simulation. Got everything we need, so just make sure that you're on this here. Also a cool thing that you can do with CMG is you can have a 3D view of your reservoir, so you can kind of take a closer look at it and use this rotate reservoir tool here to get a different look of what it looks like. So you can see the producing well there in the middle, and for some reason the thickness is unproportional since it's only 10 feet, but that's not too important. So let's go ahead and start the simulation. Click validate with IMAX. So yes, let's make sure we save this here. So you can give this whatever name you want. So we could just make this CMG homework for black oil. Click OK, and we're going to click run normally and then run it. So now you just kind of wait for a couple seconds while it's simulating the production from this reservoir. Alright, so here we go. Now these are the final results that you're looking for from, I guess, the builder. So it's going to tell you the total oil in place, total water in place, so pretty small number. I guess that's the connate water, and the total gas in place. And so these are the numbers that you're going to want to compare to your material balance and volumetric calculations. So now that we've ran the simulator, we can go back to our launcher page, and here you'll see a bunch of new files that you didn't have before. So these are produced after you click that validate and run the simulator. So the one that we're looking for is this .irf. So let's go ahead and drag this .irf into the results 3D right here. And so this is going to open up a results page, and here we can kind of take a 3D look. Really, we're just going to be looking at 2D since it helps us visualize better what's going on with the pressure. So here we can change this from bubble point pressure to just pressure, and if you just click play, then you can kind of see how the pressure is diffusing through the reservoir over time. So it's just going day by day. The well is producing, so that pressure is dropping, and you can kind of see based with these colors and how these circles are just kind of moving outwards. So I'm going to stop this here since you guys can take a look at this yourself, but you can also change the date here. So if you want to go to a specific date, see what the pressure is, just drag and drop this like that, and use the arrow keys to move to the side as well. So that's about it for this 3D results. So when you take a screenshot of this, make sure that you get this entire white square rectangle kind of region, including your user ID and the legend right here. So you could either take a screenshot or you could save the image right here as well, whichever one you prefer, and then you can post that onto your homework. So that same .irf, we can now put it into the results graph. So drag and drop here. And so this allows us to just plot different variables against each other. Um, so we're going to add a curve. Start off by looking at the pressure. So first I'm going to look at well bottom hole pressure. Click OK. And it will produce this graph of well bottom hole pressure versus time. So you can see how it's just slowly declining as the reservoir produces. So if we want to look at another curve on top of this one, we can just add a curve here by right clicking and then clicking add curve. And so let's go ahead and add this well block pressure, which is essentially your reservoir pressure, right? Click OK, and so there you can go ahead and see the difference between the reservoir pressure and bottom hole pressure. So now let's create another plot, for example, by right click on plot, add plot, and then add a curve. So for this one, let's take a look at the gas rate. So gas rate, standard conditions. See how the gas slowly, the rate's dropping over time, and then it's this pretty big drop right here. If we want to, we can also we can edit the curve, change it to something else. So let's look at the water rate. So we said that this water, we set the aquifer really low, and we assumed that there was not going to be any water influx for this reservoir. So we can double check that here by going to the water rate, clicking OK. And so it looks like there is like water production, but if you look at the units over here, it's 10 to the -5th pretty much, which is virtually nothing, a fraction of a barrel a day. So that's pretty good. And then let's compare that with the oil production. So we can go ahead and go to oil rate SC and plot that against each other. So you can see how it's about 9 barrels a day and just slowly dropping. So you can also edit these graphs a little bit, the formatting. So just page layout, page text, for example. Let's go ahead and just add a title here. Let's say water and oil rate and stock tank barrels per day versus time, days. And then you've got a title up there. So again, like the last part, you can just take a screenshot or I think save the image as well, however you like, and post these different graphs that you need for your homework. And something important to note is that you can zoom in on this graph, or well, not zoom in, but put your cursor over the graph so you can see what day had what pressures, and then using that you can get some other information of what the fluid properties might be at that time. So let's go ahead and exit out of that now that you know how to create the graphs. And so let's go back to this builder, the builder that I kept open here. So I'm going to save this as something new now, since we're going to be changing this to a dry gas reservoir. So I'm going to change the name dry gas.dat. Okay. So now basically we drop this reservoir and it's lower depth, and now the pressure is below what it was before. So we're changing up the initial conditions here. So it's no longer water and oil, now this is water and gas because it has dropped below the bubble point. And so you've just got gas inside of this reservoir. So we're going to make this pressure 1100 psi. The depth is now going to be 2500 feet. And the water gas contact, let's make that 2510. Click OK. So we changed that there in the initial conditions, but we also need to change one thing in this array properties too. So that grid top that used to be 6,900 feet now is going to be 2,490 feet since we dropped the depth. Click OK there. And the rock fluid properties are, well, we're actually going to have to change some things in the rock fluid properties as well. So let's go to the rock fluid types. Not that actually, sorry, the components. PVT region. So this reservoir is no longer at 130. This is now 90 degrees. So for this component section, even though we changed the temperature to 90 Fahrenheit here in the general section, we actually need to generate a new PVT table based on this change in temperature. So we can click here, Tools, Generate PVT Table using correlations, and now it'll have the 90 Fahrenheit there. Let's generate points up to, say, 2,000 psi since it's a lower pressured reservoir. Let's double check that that stock tank oil gravity is still 0.9. Gas gravity is 0.8, and that should be everything that you need to input. And now we can click Apply. Don't worry about this, just do nothing, and click OK. And so now you'll have a new set of PVT table data that you can use for your calculations. And so now, I think, oh, we need to change the well production as well. So we can go down to this well, expand it, go to this date here. Not the date, excuse me. Click on the producer, go to the constraints, and then change this value from 10 to 100 barrels per day. And so we can click OK. And now we're ready to run the simulation again. So this time conditions are going to change, and it should, if we did everything correctly, just be a dry gas reservoir. So you only have gas initially located inside of it, and there will only be gas produced. And there we go. So we've got no oil in place, so it is definitely a dry gas reservoir, and the total gas in place is located right here. So now that you've got all this, you can use these simulation results. Take a look at the graphs where you can look at the different gas and oil produced for your reservoirs over time, and use that along with the PVT table that was generated through CMG to figure out what that original gas or oil in place was,